This is on measures of central tendency, and we got our mean. This is measure of the center found by adding all the values and dividing the total by the number of values. Best used if frequency distribution is roughly symmetric. And we got our sample mean and our population mean. So let's look at an example of this. Get my pen to work. There it goes. That's the same formula whether you're talking about sample mean or population mean. So I'm just going to say find the mean of 3, 9, 10, and let me see, that's 12, 22, 72, 70. I'll go with that. I don't think it comes out nice, but that's okay. It's too early for me to actually add something up and make it come out nice. Let's take a look at this different notation here. Now this x with the bar over it, that's x bar. That's actually what it's referred to. That's sample mean. This u with an extra line, that's population mean. That's mu. That's Greek letter mu. This e looking thing, that's uppercase sigma. That means add together. And then it's x sub I, that's your each individual data point. So this would be x1, x2, x3, x4. And then the little n represents how many is in your sample. Like if this represents sample mean, little n would be 4. There's 4 of them. Now capital N is the number in our population. So if this represented population values, capital N would be 4. So let's take a look at this. And let's say there's sample. So x bar is going to equal to this notation divided by little n. Well, that says add together all of your x values. So I got 3 plus 9 plus 10 plus 52 divided by, and we got 4 of them. And let me plug that in my calculator here. 3 plus 9 plus 10 plus 52 divided by 4. So that gives us 74 divided by 4, which gives us 18.5. So that'd be our sample mean by hand. Okay, let's look at how to do it on the calculator. So let me come over here, clear all that out. Okay. Now first thing we got to do when we're plugging in our calculator, we do the same numbers, is we got to input our numbers. So I go into Stat, go into Edit. If you already have numbers there, you just press Delete over and over to clear those out. And we got 3, so do 3 enter, 9 enter. After each number you press enter. So 10 enter, and 52 enter. Now we're going to exit out to a second mode. Anytime you input your numbers in, you always want to exit out before you go on. So that's what this says. Input numbers in second mode to exit out. Then we're going to press our Stat button, right arrow to Calc, enter on one of our stats, and enter again. So press Stat, right arrow to Calc. You see one of our stats is already selected, so I do enter on it, and then do enter again. Now the X bar, our top one, is 18.5, which matches what we got by hand. Now X bar is also the same as mu, because it's the same formula, whether you're dealing with sample mean or population mean. So if it asks for population mean, use the same value. There is also, and I give you these buttons here, I'm not going to actually show it. I like one var stats. One var stats gives you everything. But let's say you just want to find the mean by itself. Well, you can enter your values into L1. Again, that's Stat Edit. Now, after you do that, be sure to exit out to do a second mode. Then you press your second button, your Stat button, choose Math, choose Mean, enter, second one, that puts L1 on your screen, closing parentheses, and enter. And that'll give you just the mean. I don't recommend it, because one of our stats is so nice because it gives us everything. Let's look at another example. I'm just going to do this using technology. I've shown you a very simple one by hand. So let's see, we've got 25, 33, 37, 41, 42, 58, 91, and 103. And the instructions say find the mean of the following data. Okay, so let's first go input our numbers in. So I'm gonna press Stat, go into Edit. So I did Enter on Edit. I'm gonna press Delete over and over to clear those out. Then I got 25, Enter, 33, Enter, 37, Enter, 41, Enter, 42, Enter, 58, Enter, 91, Enter, and 103, Enter. Now I'm really bad about inputting numbers, so, and if you are, you probably money ahead to go ahead and go back through and verify your numbers that you just input. That'll look okay. Now once you get those in, do a second mode, exit out. Now again, we're going to do one of our stats. So I'll press Stat, right arrow to Calc. You see one of our stats is already selected. Do Enter on it. Now it assumes L1. So if you put your data into a different list, this will not work. So I'll go ahead and press Enter. And that'll give us our mean. And I don't even know what mean it was asking for. Okay, wasn't asking for any, because they are the same formula. So mean will be 53.75. Now we got some other items here which we'll talk about later, but now let's examine mean a little closer. And I always use this example when deciding or showing people why do you need to learn statistics. Let's compare me against another teacher. I'll make a teacher's name, Bill. Okay. Now Bill, if I look at all this is for college algebra, the final grade of the student in the class. First student got a 70, second got a 70, third got a 70, fourth got a 70. All of them got 70. 100 students. Look at my students. First one's got 100, next one's got 40, next one's 100 and 40, and that pattern repeats all the way down like that. And I got 100 students. Well, if you look at the average of both of our classes, my average would be 70 and Bill's average would be 70. Now if the only thing you look at is the mean, it'll look like we both did about the same job. Both got an average of 70. Couldn't ask for anything better. They just came out that way. If you look at the actual individual data, though, Bill got 100% of his students through the course, while I failed half of mine. So 50 of my students had to either retake it, or a lot of students, when they fail, they give up and they drop out of college. So the mean really doesn't give you a true picture of what's going on with your data. We're going to see that there's something called standard deviation, which gives us a better measure of what's going on. Sometimes you have a data point that skews it. Like I go around and I ask students in class how much money they have in their account, and one tells me $2, one tells me $5, one is a minus $1. They need to borrow some from the person above them. Next person is 10, and next person I talk to has $100,000 in their account. And then I go to 2, 1, and this. You can see that most of the students don't have any money. If I take the average of this value right here is going to cause the average to be skewed, so that it looks like students have a lot of money. Might look like the average is 10,000, when most students don't, just have a few dollars in their account. So again, an extreme value can really screw up your mean. Well, there is one way to get around that without looking at the standard deviation, but this is kind of a primitive way. There's something called a trim mean. This is where you drop the smallest and largest value and then find the mean. Well, what if you got two extreme values, two very large values? This won't do that. So again, it's not perfect. Another way to measure data is the median. This is the measure of center, that is the middle value when original data values are arranged, denoted by a capital M. Different books give that a different symbol. Now, mean is always X bar for sample mean and mu for population mean, but median kind of changes. Now, this is best to use if the frequency distribution is skewed left to right. Excuse me. Now, finding median by hand. Arrange them in order. If the number of values is odd, median is the exact number in the middle. If the number of values is even, find the mean of the two middle numbers. Now here's some buttons on how to do it on your calculator. We're going to look at a lot easier way than doing this. So I won't spend much time on this. In values into L1, second stat, choose math, choose median, enter, second one, close parentheses and enter. Well, let's take a look at this one right here. We got 83, 25, 90, 4, and 55. But to do this by hand, what we have to do is we have to arrange them from smallest to largest. So here's 4. That's our first one there. That crosses away. Our next one is 25. That's gone. Next one's 55. That's gone. Then 83. That's gone. And then 90. And that's gone. Okay, so our median is the number exactly in the middle. So our median here is going to equal to 55. Let's take a look at doing it on TA3, TA4. Okay, first thing I got to do is input my numbers in. So I'm going to go in my stat, I'm going to go in my edit, and I got some numbers here. I press delete over and over to clear those out. And then we got 83, enter, 25, enter, 90, enter, 4, enter, and 55, enter. I want to exit out, so I do a second mode. Now we're going to go to stat, we're going to right arrow to calc, and we're going to use one of our stats again. So I'll press enter on it, and I'll do enter again. Now it assumes L1, so if you didn't put your data in L1, then you need to put whatever list that you did put it in. We do one var stats, and then if I, like for example, if it's an L2, I do second 2 to put L2. Now I notice in our lower left hand corner is a little arrow. That means there's more down below. So if I down arrow, I see that there's one that says MED. It says median is 55, which is what I found right here. So that's how you do it via technology. Well, let's take a look at another one. We'll do it by hand first, and we'll use technology. Okay. We got the numbers 5, 12, 2, 53, 45, and 87. I want to arrange it from smallest to largest. So 2, 5, that's gone, 12, that's gone, 45, 53, and 87. 45, 53, 87. Those three are gone. Well, this one, there was a number exactly in the middle because there was an odd number of them. Here there's 6 numbers. There's even. What we do is we take the middle 2 and we find the average of them. So I got 12 plus 45 divided by 2. That gives us 57 divided by 2. Is that 28.6? Or 0.6? Can't do basic math. 57, double check with my calculator. Yeah, 28.5. So that's our median. Now you might be looking at these examples and think, well, it's not that hard by hand. I think I'll just do it by hand. Well, when you got 40 numbers and you need to arrange them from smallest to largest. That's very tedious. And then trying to figure out what your middle numbers are, not so easy. I'm working very simple problems by hand, but realize technology is better. So let's do it on our calculator. Okay, so I'll press Stat. I do Enter on Edit. If I have numbers already, which I do, I'll press Delete over and over until they're gone. Okay, so we got 5, Enter, 12, Enter, 2, Enter, 53, Enter, 45, Enter, and 87, Enter. After you get your numbers input, go ahead and exit out, do a second mode, and we'll press Stat, right arrow to Calc. Now we'll choose one of our stats, and again, it assumes L1. If you got a different list, then you do like second 2 for L2, second 3 for L3. I could put L1 there if I wanted to. Do a second 1, and I'll put L1 on there. You don't have to. It assumes L1 if you don't put it. And our median is on the second page, so I have to do a down arrow over and over. Tells us our median is 28.5, which is what we found by hand. Okay, let me save this page. Yes, measures of Central Tennessee. Page 01. There we go. Now a note: a numerical summary of data is said to be resistant, not very, if extreme values, very large or small, relative to the data, do not affect its value substantially. You know, if you got a million data points, and one of them is extreme, well, spread out over those million, it won't make much of a difference. Now, if I only have 3 data points and one of them is extreme, then it'll definitely affect it. So that's what resistant refers to. Let me make this big so we can see this. Now, the relation between the mean, median, and distribution shape. The distribution shape. If it's skewed left, mean is substantially smaller than median. If it's symmetric, mean is roughly equal to the median. And if it's skewed right, the mean is substantially larger than the median. And you see that's represented in the pictures down here. Now, if the data are skewed left or skewed right, then the median is a better measure of central tendency. If the data are symmetric, the mean is a better measure. Going back to my example of students' amounts they have in their checking account. And I'm only going to do like 5 items, but it'd be the same as we have 300 items. First person's 1, next one's 2, next one's 5, next one's 11, and next one tells me 100,000, or let's see, 100,000. Okay, this is arranged from smallest to largest. The median would tell us it's 5. The number exactly in the middle. See how it avoids this extreme value here at the end? So again, sometimes if it's skewed like that, then this is a better measure. Where mean will probably give us something like telling us 20,000, which doesn't represent, it's complete garbage. Okay. Now this fourth one here says decide if the mean or median is a better measure for the data on the right. Well, to decide which one to use, you have to see how it's arranged. You know, if it's skewed left, skewed right, or it's symmetric. Well, I'm going to show it 2 different ways. I'm going to show it in Excel, and then we'll show it on the graphing calculator. Now, if you're in my class, I'll never ask you to come up with a histogram on a test. That's kind of tedious. So you're welcome to do these in Excel, because I think they're so easy. I do 90, 84, 90, 91, 73, 85, 83, 90, 97, 19, 45, 78, 71, 90, 72, 76, and 91. It looks like I entered them all right. Okay, now before you do this, if you've never created a histogram on your in Excel, you first have to go into File, choose Options, then down to Add-ins. Then down here where it says Manage Excel Add-ins, you click the Go, and you want the first two selected: Analysis Toolpack, Analysis Toolpack VBA. Actually, VBA you don't need, but and then you click OK. You don't have to do that but the first time. Well, under the Data tab over here, there's Data Analysis. And we choose, let me cancel that. Note our data is from A1 to A17. Okay, now go into Data tab, Data Analysis, and I will choose the histogram. Choose OK. Input range. I'll put A1 colon A17. And I want to choose chart output down here, and then click OK. Now it looks like all my data is over here on the right side. Well, that's skewed left. It's always opposite what you think. Since all my data is on the right side, it's skewed left. So, back to here. I said if the data is skewed left or skewed right, then the median is the better measure. So for this problem, the median is the better. Well, let's take a look at how to create that histogram on a TI-3, TI-4. First thing I got to do is I got to input my numbers. So I'll press my Stat, and I go into Edit. If I got numbers there already, just press Delete over and over until they're gone. Okay, 90, 84, 90, 84, 90, 91, 73, 85, 83, 90, 97, 19, 45, 78, 71, 90, 72, 76, and 91. Assuming I typed in all my numbers correctly, which is always kind of iffy with me. Now we're going to exit out, so we'll do a second mode to exit out. Now if I press Y equals, I want to make sure I don't have anything on Y1 from a previous problem. To create a histogram, we'll do a second Y equals. We want to choose the first one, so do enter on plot 1, plot 1. The options we want to select the on, so do enter on. That'll highlight it. I'll down arrow, and for the type we want the third one chose. So right arrow over to the third one, put your flashing cursor on it, and press enter one time. And it should default to L1 and 1 here, which are fine. If you don't have those, you down arrow to this, and you do second 1 to put an L1 here. Now frequency, if you don't have a 1 here, it's by default in alpha mode, so you have to click your alpha button one time, and then you press your number 1. Okay, after you get that in there, then you press your zoom. I hate this new calculator here. Okay, never mind that. I'll exit out. Do a second mode, then press your zoom. And then up arrow. We're looking for the zoom stat. So there's our zoom stat, and I press enter on it. And that'll give us our bar graph there. And you see the data looks like it's mostly on the right side. So it's skewed left, when the median's a better measure. Again, Excel is the easier way to create a histogram. Anywhere, if you're in my class, it asks you to create a histogram, plug it into Excel, assuming you have Excel handy. It's so simple. Let's talk about the mode. This is the value that occurs. Sorry, I'll learn to speak someday. The value that occurs most frequently. Now, bimodal, two values occur at the same greatest frequency. Multimodal, more than two values occur at the same greatest frequency. Mode is often used where a measurement is names, categories, etc. Let's look at an example of that. Example 5 says find the mode of the following data. We've got red, red, blue, blue, red, red, yellow, yellow, blue, red, red. Well, we got 1, 2, 3, 4. We got 6 reds. For blues, we got 1, 2, 3 blues. For yellows, we got 2 yellows. So the most we have is red. So our mode is red. Now this one, we got black, yellow, red, orange, mauve. Well, yellow or red, orange, and mauve only occur one time. Black occurs twice, yellow occurs twice. So our mode is black and yellow. It's bimodal. Means there's 2 that occur at the same greatest frequency. Now, if none of them repeat at all, they all just occur one time, there is no mode. It's not that every one of them is a mode. Last one we're going to talk about is a mid-range. Now, I don't got an example of this, but the value midway between the highest and lowest value in the data. So you take your high value plus your low value and then divide that by 2, and that'll give you a mid-range. It was such a simple calculation, I didn't figure I needed to show that. And that's actually the end of that one. So let me save this page. Not that there's that much on it. There we go. And there's a recorder. And stop both recorders. There we go. Let's stop the other one.